Welcome everyone to another edition of Willow's Weather Briefing. Today is Sunday, May 25th, 2025. Today we have an enhanced risk of severe weather over northern Texas and much of Oklahoma. We also have a concerning flash flooding risk over areas of the Boston Mountains and eastern Oklahoma. We also have heat continuing down in southern Texas and also the Florida Panhandle. Also some fire weather risk in the southwest. Much cooler temperatures across the northeastern United States and northern tier of the United States, and much warmer temperatures ahead for the western United States. Here is our composite radar and satellite imagery. As you can see, we already have training storms in our flash flooding risk area, and that is just going to continue to train across the stationary front, allowing for the moistening of soils and, of course, precipitation, which is all conducive to the flash flooding risk here. So that is sort of our main story. We also have an enhanced risk of severe weather down here, much clearing ahead of this severe weather episode, but our main concerns here are going to be hail and wind. And also we can just generally see the disturbance in the western United States with all these clouds over here and this broad low pressure system spinning up here in the Great Basin. Also much cooler temperatures, very gloomy, cool, but overall fair weather in the Northeast. So here's our storm reports from yesterday. Not much really happened. We didn't really see storm initiation during peak heating, which sort of mitigated our tornado threat. But we did see initiation along that dry line in Texas, which caused one tornado report down here, and also a swath of wind reports. Some hail reports scattered along here, but definitely the tornado threat did not materialize as much as expected, and overall the spatial coverage with all hazards was pretty low because we didn't get that initial run of convection, which happens. I mean, we just didn't get enough convergence along this modified outflow boundary / warm front, so storms just didn't initiate and didn't break the cap that ended up building in Oklahoma. So here is our drought monitor. The solid lines demarcate the areas of most concern with the drought, so please pause the video if you want to see about that. Here's our current watches and warnings. Freeze watches or frost advisories up here in the upper Great Lakes into the UP of Michigan because of very cool temperatures here in the northern United States all over. We also have a swath of flash flood or flood advisories or flood warnings, flood watch, not the right name, across central Oklahoma to the Ozarks and south to the Arkansas Valley. We also have severe thunderstorm watch in southeast Kansas associated with that training convection, and a few severe thunderstorm warnings and flash flood warnings across the areas. We already have some flood reports here around Tulsa and eastern Oklahoma. So, of course, please be prepared for any flash flood warnings. Flash flood warnings can be dangerous if you live in any flood-prone areas. Make sure you know where higher ground is and make sure you have all your property set for any flash flooding. Here is our surface analysis chart. Today, the main cause of our severe weather and flash flooding is this meager surface response that's causing this continual battle between this high pressure up here and this low pressure down here. We've been talking about this. It causes the stationary front that sort of wiggles and wobbles based on this low pressure response, and we just see training convection along this what we call a baroclinic boundary between two air masses with different densities. So we have a swath of flash flood risk co-located with a severe weather risk over here from the from West Texas, Northwest Texas, all the way to portions of the mid and deep south. Day 2, this pattern kind of continues, but sort of starts to change. I mean, the past few days we've had this similar pattern, but our pattern will start to change a little bit. So we have a low pressure system still along this baroclinic zone, and we will have a severe thunderstorm risk here in central Texas, but that flash flood risk will continue onwards as long as we have this stalling boundary. Day 3, again, our boundaries are still in place, but not too much moisture return at this point since we have sort of a lackluster low pressure or surface response at this time, but widespread rain expected on day 3 Tuesday. Here is our excessive rainfall outlook. Moderate risk for much of eastern Oklahoma into far northwestern Arkansas, also down the I-35 corridor towards the Red River. We are expecting a surplus of 3 inches of rain in these areas, which is definitely enough to cause some gradual flash flooding concern in these areas. But a slight risk region exists around the Red River over towards the Mid-South regions. Day 2, the slight risk expands and contracts east. We have a slight risk over here in northeast Texas over to the Mid-South and portions of the southeast. Day 3, that boundary continues to move off to the east and south, bringing a wide swath of marginal risk and gloomy weather to all of these areas from the Ohio Valley, mid-Appalachians to down towards the Mexico border in southern Texas. Day 4, the boundary finally starts to sweep away. We have a marginal risk over here in northeast Carolina up towards Delmarva. We also have a marginal risk mainly associated with some convection over here in Texas towards Louisiana. And day 5, Thursday, marginal risk associated with some disturbances moving in for eastern Texas and Louisiana. Here's our fire weather outlook. We only have a day 1 for today. Elevated fire risk in portions of the southwest over towards the far western portions of Texas, such as El Paso. Here's our convective outlook. Today, enhanced risk over areas of northern Texas towards the Texas Panhandle over towards the southern half of Oklahoma. This includes cities like Oklahoma City, Lubbock, Wichita Falls, and Lawton. Main risk for today is going to be wind and hail. 30% hatched risk for wind in these regions associated with quick upscale growth and dominant outflow. We also have a hail risk for these regions associated with low level instability than we were working with previous days, but still big hail is expected in these regions. Tornado risk, still a risk of tornadoes. Don't get me wrong, a 5% unhatched risk for these areas and the enhanced risk. But as far as what I've seen, the tornado risk is a little bit lower than what we had previous days, so this is not going to be our primary concern. But could there be a tornado there? Of course, yes. So we have a slight risk tomorrow in areas such as central Texas. The main threats here is going to be hail. Big hatched risk over there in central Texas. This includes cities like Abilene, San Angelo, Big Spring, Brownwood, Sweetwater. And a 15 unhatched risk of severe weather that extends further to the east. That includes the Dallas-Fort Worth regions and over there towards the Louisiana border. We also have a small tornado risk right now, 2% for these regions. Day 3, a wide swath marginal risk associated with the stunting of that front to the south. Widespread severe weather. It's possible, but overall pretty low risk. And this extends all the way from the Mexico border region towards the Big Bend and all the way towards areas such as Jacksonville. No extended range outlook right now because of predictability. So let's take a look at the heat risk here. We have a wide swath today of heat risk over from Texas all the way towards central Louisiana. This whole entire area is under some major heat risk expected, perhaps some extreme heat risk. Sorry about that. And we expect some areas of extreme heat risk here in the more deserted regions of southern Texas, but overall, a wide swath of triple-digit temperatures should bring major heat risk to these areas. This has also been here for a long time. This heat has been here for a long time. I've been talking about this for a while now, well over a week. So little to no relief in these areas will cause some heat risk for any heat-sensitive industries or infrastructure. Over here in Florida, we have some heat risk, especially in the urban areas that don't get that relief overnight because of what we call the urban heat island effect. It sort of traps all the heat, and we have less radiative cooling over here in these urban areas. So areas like Miami, the Florida Keys, and Tampa are of special concern for these above average temperatures here in the Florida Peninsula. So if we move on, the heat sort of starts to deplete in the Gulf Coast. Florida is still hanging on to the heat for a little bit towards midweek. But as we get to midweek to late next week, our heat risk focuses on the western United States, which heat starts to build over here, especially towards the Central Valley and Great Basin regions. So here in Chico, Redding, California, the northern California Valley, highs in the mid triple digits progged for late next week, which is well above average for the Central Valley. I know the Central Valley usually gets hot, usually doesn't get this hot because thanks to an upper level ridge that's sort of building in this area. Further south, Central Valley, still temperatures can reach up to triple digits into late next week. And then Great Basin region, such as Las Vegas, temps in the low hundreds, which is still above average for these areas, despite usually having high temperatures in these deserted areas and also in the Central Valley. Here's our 6 to 10 day temperature outlook: above average for much of the western United States, below average for much of the central to eastern United States, and above average for the Florida Peninsula. 6 to 10 day precipitation outlook: below average for much of the northern United States, above average for much of the southern United States. Oh, I'm missing something here. All right, so let's take a look at HREF here just to take a quick gander at our storm coverage for today. We have these ongoing storms. Right now I'm recording this at around 1Z. So we have ongoing storms here in southern Kansas through the eastern Oklahoma regions to northern Arkansas. We have those flood warnings, flash flood warnings, and flood reports in Tulsa and surrounding areas. That will continue throughout the day over in those regions, but our main corridor of severe weather risk won't be really until 2 to 3 p.m., which will see development both along the dry line and further development along the stationary front as we get the sun to heat the ground, cause further instability in the atmosphere. So we'll see development along the dry line around probably 3 p.m. today, and those storms are prone to grow fairly quickly upscale as we get into sunset. And when we get into sunset, it'll further induce the upscale growth of these storms, and that is why we have the 30 hatched wind threat. We also have that hail threat for any semi-discrete storms that can develop more robust hail cores, especially early on in the evolution. The more that these storms can remain discrete or clustered, the more chance you'll have for hail. So let's go ahead and look at our upper air look at the GFS today. Here we have we have the polar jet all the way down here, possibly a semblance of the subtropical jet moving into the Four Corners region. And the subtropical jet will continue off towards the east. Polar jet kind of stops splitting, moves way up to the north, causing this massive ridging over here in the northern United States. So above average temperatures for much of the far northern United States, such as the northern plains, expected. So we expect this pattern to sort of move east, this disturbance over here, this troughing, to move east. And we also expect a pretty complex system of trough short waves and upper level lows to really impinge the United States. So this trough down here, this upper level low that's sort of spinning across the northern United States into the west, and this associated trough that's sort of pushes into the United States, will bring another shot of cold air that will bring an end, at least temporarily, to our heat in the southeast. But as you can see, we have a ridge building over here in the western United States, which brings our above average temperatures for much of the Central Valley and Great Basin regions. Let's look at our surface pattern here. High pressure over the Canadian Shield. Low pressure over here in eastern New Mexico. Stationary front right about here across Kansas into Arkansas. So additional precipitation today, not that surprising. And we will see that precipitation move towards the southeast tomorrow. We will have reinvigoration of some convection because of more mesoscale forcing mechanisms like the dry line. Probably some meager surface flux from the Gulf of Mexico because of this low pressure system that's sort of sitting over the Chihuahua Desert. And then the precipitation again migrates east. And then on Tuesday, another reinvigoration of convection across that dry line. Dry line is definitely sort of a semi-permanent feature this time of year. We see a tightening of the dry line, additional forcing as we get to peak heating, which is usually around 4 p.m. at this time of year. And then that precipitation will continue east again, and then we see continual development across the dry line for multiple days. So some rain showers expected widespread across the eastern United States this week, and also possibly some rain coming into the Pacific Northwest late this week as well. And also some rain up there expected tomorrow, this evening into tomorrow as well. Take a look at our temperatures. Temperatures up to the triple digits in portions of southern Texas, high 90s over there in Florida. The main concern of the heat in Florida is not necessarily the high temperatures, because you can handle 90-degree heat and humidity down there in Florida. It's what you can't really handle is the lack of any relief at night. Usually temps can get down to at least the low 70s down there, but in urban regions we don't expect temperatures to get down that much, probably up to the upper 70s. Cooler than average temperatures for much of the northern, central, and northeastern, midwestern United States. So you can see pretty chilly over there in areas such as Nebraska. But again, heat continues over there in areas of central, in areas of southern Texas. And then we finally get a depletion of that heat by mid to late next week. But then heat starts to build in the Central Valley of California starting midweek next week, really not peaking until later, such as Thursday, Friday, especially the weekend. So the GFS is really mean to you guys on Friday. Temperatures soaring all the way up to the mid triple digits over there, even in areas such as Sacramento. So we got to watch out for extremely hot temperatures over there in the west, hotter than even portions of the desert southwest. Heat continues, even, I mean, the GFS on Saturday even has temperatures all the way up to 110 degrees in Redding. Take a look at our dew points here. Sufficient moisture for severe weather over there in the south, and then that will sort of just continue sloshing at least until mid to late next week, as we get that cold front pushing in with that high pressure system pushing into the Gulf and sort of sweeping off our moisture for a bit. So let's take a look at our ensemble. I'm pretty curious to see what the ensembles say about this heat. in the Central Valley. So again, this far out, by late next week, you start to want to look at the ensemble approach, which looks at multiple, what we call members of a model, which basically perturbs or changes the initial conditions of the model to get a slightly different solution. And over here, you can see that there's still quite a bit of uncertainty to the temperatures in the Central Valley. It could be up to the mid hundreds, but could be as low as the mid 90s. But again, think of it in context. We have this big upper ridge building, so most likely temperatures are going to be well above average for this area. So we want to think about that, the meteorological context. So I think the National Weather Service is on point of taking the middle ground, but extending the temperatures a little bit in favor of the 90th percentile, which is the higher value that you see there. So yeah, expect temperatures in the low to mid hundreds throughout the Central Valley, especially in northern portions, because that's what the National Weather Service says, and they know more than me. But again, these models kind of prefer the southern portions of the Central Valley, such as Fresno. So just see how the models evolve and see how our heat outbreak there starts to unfold. So finally, let's take a look at our severe weather today. We have lingering convection moving off from the east, which might modify our environment just a little bit in these regions, perhaps bringing out an outflow boundary, focusing our convection along the stationary front, or modifying our stationary front just a bit. ARRR shows immediate widespread convection over this area, starting at around 21Z 4 p.m. along the dry line. And that kind of turns into a mesoscale convective system that will move across the Red River over to Arklatex and towards the southern Mississippi River Valley. And let's take a look at our dew points on the ARRR. A lot of moisture pooling in this like reinforced boundary that we see here, possibly modified by our outflow boundary. Kind of similar to what we saw yesterday. Dry line situated not that tight, but situated over here in western Texas. That will be our focus for severe weather for today. These storms these storms form off of this area of the dry line right here. And then sufficient moisture up into the high 60s to low 70s. So definitely sufficient dew points for thunderstorms. Take a look at our severe thunderstorm parameters. Look at our mixed layer CAPE. CAPE sort of depletes with northern extent because of that outflow boundary sort of shunting off the warm front a little south, but we still see a good recovery of mixed layer CAPE, especially around the Red River region in southwestern Oklahoma towards Lubbock. We see just storms eating away at that instability. Instability values up to 4,000 joules per kilogram according to the ARRR. Let's look at our mixed layer convective inhibition. Starts off strong with the lack of diurnal heating, but slowly depletes away as we get peak heating. Shouldn't see any problem with convective inhibition. There is some meager amounts, but because of dryline forcing and also possibly the help of that modified boundary, we should see no problem seeing convective initiation. Looking at bulk shear here. Not too much bulk shear to work with at first, but as we see that wave start to impinge into the area, we do see some amounts of bulk shear, not too much, about just sufficient enough to sustain things like supercells and organized convection. We also see kind of a southward advance of some thunderstorms over here on this boundary as well. Organization of convection kind of looks a little slower today, perhaps, which is probably why there's only a 5% risk of severe thunderstorms, but, or sorry, 5% risk of tornadoes, but still should be sufficient enough to sustain some organized convection. Speaking of tornadoes, storm relative felicity at the lowest levels kind of minimizes towards peak diurnal heating. Not too much storm relative felicity to be had for these storms, which is again perhaps why we don't really have that much of a tornado risk, as these storms kind of take advantage of the kind of meager but still there low-level jet. Could see some linear organization of that now linear system, and that will move off across the Red River into the Louisiana and Arkansas region. So the low-level jet can help us sustain especially linear convection, but it can help sustain all forms of convection, but particularly linear convection. And let's actually take a look at our low-level jet response here at 850. So again, it goes away with peak diurnal heating, but definitely ramps up, as you can see here, ramps up and helps us sustain some of that convection. This can also help us organize a bit of that convection as we increase that bulk shear value towards the end. So in my opinion, storms will initially kind of struggle a little bit to organize, get their act together. So I do believe that the tornado threat is just where it's supposed to be, but towards the nighttime, we should see some more organized convection. Of course, initially, we're on the threshold, but due to the amount of cape we have, perhaps storms will organize a little bit into clusters and cellular modes, possibly, primarily for large hail, though. I don't think the parameter space is really too conducive for something like tornadoes. But let's go ahead and look at that a little bit closer by using our atmospheric soundings. So over here, you can see sort of my thought process in action here. So a lot of instability in the atmosphere, especially at the upper levels. At the lower levels, kind of not too much. 41.3 cape, LFCs and LCLs pretty darn high. But if you want hail, then this is the place to be. You even see some negative storm relative felicity here, especially with the left movers, which will sort of promote a little bit of leftward moving supercells. Bulk shear is just enough to support supercells, surface to 8 kilometers, not too much surface to 6 kilometer bulk shear, but should still be sufficient to support very deep updrafts. Because of these temperatures, dew point spreads, your downdrafts will be pretty powerful. So this might be a little bit pulsy type thunderstorm development. We're not really going to see the quasi-steady classic supercell type things today. I just don't think that's going to happen. Nonetheless, still a pretty good hail look, as you can see with our analogs here, of course, but just based on our ingredients, pretty straight photographs, meager low-level instability, and lots of instability aloft. Let's go ahead and move forward a little bit in time. You can see the quick upscale growth that we'll see over here. And let's just take another sounding, probably along the Red River here. And as you can see, the low-level jet kind of does a little bit of work in enlarging your photographs at the lowest levels, but due to the just not a lot of surface-based instability at all. So by this point, our storms will probably be elevated and or organized into a more linear system. We even have less bulk shear than before. So I do believe that this might be a little bit of a problem in sustaining a really insanely robust linear system. But perhaps later on into the night, as we see this bow echo start to form in simulated reflectivity, yeah, this is a bit better what you kind of want to see in terms of organized convection. You have much longer photographs, even semblance of some storm relative velocity at the surface. It's pretty interesting. Fairly low level lapse rates, which is expected this late at night. This is 2 a.m. But perhaps a fairly prolific linear system ahead overnight into areas such as North Texas, areas like Dallas-Fort Worth, into areas like Paris, Texas, and Texarkana. Should be on the lookout for a fairly prolific linear system that might occur, at least brought by the ARRR, and the environment just seems decent for a storm system like that. So let's not only look at the ARRR, let's look at how the NAM's handling it. Very outflowy looking storms on the NAM just at first glance, but let's go ahead and take it at similar places at similar times. Much more classic temperature dew point spreads on the NAM, but the kinematic profile, it kind of remains the same. Meager bulk shear, not too much storm relative velocity at all. High temperature dew point spreads, which will support our outflow, and high LFCs, LCLs. So again, you know, this might be conducive for something like hail because we have those deep updrafts in the upper levels, but something like tornadoes, not really looking at that sort of hazard primarily, at least, but hail and damaging winds for sure. Definitely more outflowy on the NAM, as you can see these kind of bowing outflow boundaries on the simulated reflectivity. But let's move on towards 1Z. Interesting. We see a continuation, probably that low-level jet transporting some extra moisture up there into the Red River region, but the NAM showing a pretty different solution than the ARRR. Low LCLs and LFCs, fair bit amount of low-level instability, so maybe the NAM is a bit more conducive on something like transient tornadoes along this line. But the NAM does show a more linear organization, less robust than the ARRR, but still a fair amount of linear organization ahead. We can see the SRH, the shear at the low levels really extending and enhancing because of that low level jet, and still we have sufficient upper level instability to really support those types of thunderstorms. All right, that is going to be it today. Oh, sorry for this, the flashing lights epilepsy warning, Jesus. So that is going to be it for today. If you enjoyed this weather briefing, please leave a like and subscribe. Leave a comment if you have any constructive criticisms. And as always, if you want any specific information regarding timing and or intensity of the weather near you, please refer to your local broadcaster, National Weather Service meteorologists. Thank you and have a great day.